All right, everybody. Welcome to lesson 3 of Unit 1. And this right here is going to be Intro to Matrices. Now, matrices are something that a lot of people don't really have a lot of experience with. There's not really a dedicated class on them. And a lot of times it seems like you're meant to just pick up the information as you go along. Hopefully, you get enough of it. For the most of you have not heard of a matrix since your Algebra 2 class in high school, but they are one of the most handy things to know how to do in order to solve some complicated systems. And we're going to use them in Calculus 2, Calculus 3, and Calculus 4, which is differential equations, to solve complicated systems and to get the values in a way that frankly, doing it by hand would take forever or be way more complicated than it has to be. So the first rule of dealing with matrices is to just kind of figure out how to convert something into a matrix. Now, a matrix, if we look, is just a table of values. You can see right here, let me switch to a different color here. You can see right here I have a system of equations. And all a system of equation is it's multiple equations as my problem. So I have equation 1 and equation 2. And you can have as many as you want, 3, 4, 5, 6, 7, or 8. There will be sometimes in differential equations where we'll have 5. And when you get to your electrical circuits classes and you're doing Kirchhoff's laws, you could have 7, no problem. And if you're trying to do those by hand, it could be very painful. And you'll notice that when we convert this into a matrix, all I'm doing is taking the numbers. The letters fall away. So I am just taking the numbers. That's it. I'm not putting letters in there at all. Now you can put letters in a matrix, and there will be times, especially in differential equations, where we do. But for now, we're not. Okay. So just notice, however, when you're doing this, I do want to point out that we are just taking the numbers, but that's because our problem was lined up correctly. All the x's were in a row, all the y's were in a row. And then the numbers without letters were all in a row by themselves. So everything was lined up, and so we could just carry them straight down into our matrix. Okay, so if you have these things out of alignment, you can't do anything with them. You have to realign them first. Okay, so let's look at this system right here. And here's what I mean by realignment. You'll see that all the x's are in a row right here, but right here you've got y, z, y. So there's some stuff that's kind of missing out of this problem. So what I'm going to do is I'm just going to rewrite this as 8x plus 9y plus 0z equals 20. I put that little spacer in there because that problem had no z's in it whatsoever. This one right here is going to be 1x plus 0y minus 4z equals 13. So you can't just leave things off. If something is missing and you want to use a matrix, you are going to have to plug in 0 for it, okay? So you cannot just leave things off. There is no easy way to do a matrix. You have to put the work into getting it lined up, and then the easy part happens. Actually, this last one messed up. I'm just going to move that 6z over, and that'll become a negative 6z, and then I've got 0 left behind. So this right here is my new system. And now I can just carry all of these things down. Now that they're all lined up, I can carry them down into a matrix. No big deal. So this will be 8, 1, 5, 9, 0, negative 4, 0, negative 4, negative 6, 20, 13, 0. So here is my matrix. Boom. So this is my matrix right there. So step 1, let me write that in there. Step 1, align the columns. Step 2, convert into a matrix. And so we're done. And then if I wanted to, I could type that into my calculator and solve something or do whatever. Or into a computer program. No big deal. Okay? So what about a vector? Notice how a vector looks very, very, very similar to what we just did. Replace that I with an X, and the J with a Y, and the K with a Z, and we're right back to where we were on the previous problem. And if you remember from any physics classes that you may have already had, I stands for X, and J stands for Y, and K stands for Z. So this is just another way of doing that. So this is good, but I do need to straighten this one right here. It's missing a J, or in this case, a Y. Remember that J's are Y's. So the first thing I have to do is convert it over, and then once I've realigned everything, then it can be placed in a matrix form, just like so. Okay? Any questions about that one? Any questions at all? Now, I would say that when you're using vectors, a lot of the time that top row is IJK. Not always, but a lot of the time when you're in physics class, that top row will be left as those three letters. And that's where sometimes we do put letters into a matrix. We'll do that a little bit in Calc 3 and a lot more in Calc 4 as we're using a matrix to find eigenvalues and eigenvectors. Okay. So let's look at this right here. So let's say that this is our values. So I'm just going to clean this up a little bit. That's going to be 1J plus 1, I'm sorry, that's an I. J minus 8K. And this right here, minus 4I plus 6J minus 11K. Okay. And now that I can just place this straight into matrix form. I, 1, negative 4, J, 1, 6, and K, negative 8, and negative 1. And right here, I've placed this into a matrix that I can use. Now the downside, since it has letters, this I will have to do by hand, which I'll show you guys. No big deal. All right. So now that we've talked about how to convert a problem into a matrix, what do you do with it after that? Once you have something converted into a matrix, 99% of the time, you're going to then do what's called a determinant. And what a determinant does is it's a version of cross multiplication. It's going to convert this matrix into a single value. So the determinant of 5, negative 2, 8, 7, what we're going to do is we're going to go diagonally down. So that's going to be 5 times 7 minus diagonally up, negative 2 times 8. And you do have to go in that order. Okay? Down minus up. It does need to be a specific order. And what's going to happen is when you get done, you're going to have a single value as your answer. Now that value, a lot of times, is a very important number. In physics, it's found that there's a lot of things that can be equal to, and then in math problems, there's a lot of things that this can be used. So that determinant is very, very useful. The majority of the time trying to deal with matrix, that is that determinant. All right. So how do we do one of a 3x3? Now, you could use your calculator to do this, but I am going to show you how to do a lot of these by hand, and there's one reason. The reason is that doing it by hand will help you a little bit more on your engineering tests. For your test to become an engineer, you're not really allowed to use a calculator, and very few scientific calculators actually have matrix buttons. Some do, some do. So if you find one of those are great, but not all of them. So I will show you how to do this one by hand. What you do is this top row gets written 4 minus 7 plus negative 12. Okay, so I do want to say that the negative in the middle is part of the formula. Okay, so that negative there is part of the formula. If the 7 was also negative, it would turn positive. Okay, now what goes inside? So here's the tricky part. Right here, when I'm dealing with the 4 out front, I ignore this column. So it's just going to be 6, 1, 4, 5. 6, 1, 4, 5. In the middle, ignoring that column, so it's just going to be 0, negative 3, and 5. Basically, I'm ignoring that, and that's just going to leave me with 4 numbers that just pop in. So for the last one, that's negative 12, I'm ignoring those numbers. So that's just going to be 0, 6, negative 3, 4. Okay, and then to finish this out, all I'm going to do now is the determinant. So it's going to be 4 times 6 times 5 minus 4 times minus 7, 0 times 5 minus 3 times 1 minus 12, 0 times 4 minus 3 times 6. So that's going to be 30 minus 4 times 4, so that's 104, minus 21 minus 3 times 6 is 18 times 12, 216. And so that's going to be 104 minus 21 minus 216 gives us a determinant of negative 133. Now keep in mind, the determinant is just a number. It can be a fraction, it can be a decimal, it can be 0, it can be positive, it can be negative, no big deal. So it can be a lot of different things. Now, there is more than one way to find the determinant of a 3x3. This is the method that I choose to use because you'll see that when we do a problem a little bit later on in these notes, it helps to keep it separate. There's a reason I chose this particular method. but there is more than one method. So if someone's taught you a different method, it's fine, it'll work. I feel like this is the easiest method if you're not going to use a calculator. That's just my personal opinion, but there are people who have other opinions. Now let's use this. Where do we use a 3 by 3 and we take the determinant? That's going to be the cross product. Now those of you who've had physics, you might remember something called the right-hand rule. This is the mathematical version of that. The right-hand rule is where you take your right hand and you grab a hold of a cable. You point your thumb in the direction of the current. You point your you point your finger in the direction of the electric field, and your rest of them are in the direction of the magnetic field. And it creates, and what it creates is it creates three perpendicular shapes. And that is the right-hand rule. Well, mathematically, that's a cross product, and that comes up a lot, especially for electric fields and for things like torque, okay? And that's when we leave this top row as IJK. And it's going to come up a few times in Calculus 3 because a lot of the math we learn in Calculus 3 is tied to electricity. Okay, so let's work one of these. So I'm going to find R crossed with V. And so I'm just going to write I, J, K. So that's 2, -3, -1, and then 1, 4, and -2. Boom. Okay. Now I'm going to do this by hand, just like we talked about before. That top row is going to come down. And so that's going to be I times a bracket minus J times a bracket plus K times a bracket. So these values are just coming down. Okay, remember that that negative in the middle is part of the problem. Okay, and then for the I simply cover up this row, and then my four numbers are -3, -1, 4, -2. Okay. For the J, I'm going to cover up this middle, and that's going to leave me with 2, -1, 1, and -2. And then for K, I'm going to cover up this third row in the column, and that's going to leave me with 2, -3, 1, and 4. Now I'm just going to do their diagonal multiplication. So that's simply going to be -3 times -2 minus a -4. So that's going to be 2i. And that's going to be -4 plus 1. So that's -3. J. And that's going to be 8 plus 3. So that's going to be 11. Okay. So the cross product of R cross V is equal to 2i plus 3j plus 11k. And we have found the cross product. Now, to give you guys an idea, what we're actually finding, so this right here is the answer, just to give you an idea. So let's say that R, and this is something that we'll do again in Calculus 3. Let's say that R is this vector right here. Remember, a vector starts at the origin and goes off in one direction. So there's R. And let's say that V goes off in a completely different direction. Remember, from the origin. Let's say it goes here. What the cross product guarantees is the answer to the cross product is perpendicular to the original two vectors. No matter how they are to each other, the cross product is perpendicular. It's a 90 degree to both of them. And that's that part, that thumb part. So right here is R, right here is E, the scissors of the base of the right hand. And then cross product, boom. That's that thumb that sticks straight up or straight down if it's negative. And that will give you a perfectly 90 degrees. Now, where is that useful? Let's say you're building something, you're doing construction. Most surfaces are not perpendicular. Most surfaces on Earth are not super flat. They're not perfectly flat. Well, you can take two vectors that represent the surface, the base, and do a cross product on them and get a bearing perfectly perpendicular. If you wanted to do like a pole or a cable suspension, or build a perfectly straight up and down wall or fence or whatever, you can use the cross product to be perfectly 90 degrees. All right, so let's do this one right here. Now, RREF is what we're going to use later on in Calculus 2. And this is a very useful way to use it when you have a system of equations. Now, RREF has to be done on a calculator. You can do it by hand, but it is a major pain in the butt. I honestly, it's been so many decades since I've done it by hand that I'm not even trying. I wouldn't even know how to do it anymore. The first thing we have to do is get everything lined up. 2x plus 0y plus 1z equals -1. 2x plus 3y plus 4z equals 8, and 1x plus 1y plus 2z equals 4. And so now that I've done that, I can put this into matrix form. 2, 2, 1, 0, 3, 1, 1, 4, 2, and -1, 8, 4. Okay. So now that I've got this in matrix form, I'm ready to type this into my calculator. So let me switch over to my work computer, and I've got a graphing calculator pulled up. Okay. So all I'm going to do to get the matrix is your matrix is along this left-hand side right there. So I'm going to go second, matrix, and then right here's the matrix. So I need to edit that matrix. So I'm going to go over to edit and hit enter. And then the first thing you can edit is the size. So this one has 3 columns and, I'm sorry, 3 rows and 4 columns. And that's exactly what I need. But you could change this if you wanted to, and it would adjust. So I just took one of the rows off. So I'm going to actually do need that 3rd row. Okay. So I'm just going to go down and type in my numbers. 2, enter. 0, enter. 1, enter. Now for the negative, make sure you use the negative sign down here at the bottom. So that's -1, enter. 2, enter. 3, enter. 4, enter. 8, enter. And then at the bottom row, 1, enter. 1, enter. 2, enter. And 4, enter. Now that I have everything typed in, I'm going to go second, quit. Okay. And now I'm going to go second, matrix. And I'm just going to hit enter to select that matrix. And I just want to double check and make sure that I have everything typed in. 2, 0, 1, -1, 2, 3, 4, 8, 1, 1, 2, 4. Okay, so I've got everything typed in. Now I can do RREF. And so I'm going to go second, matrix. And now I'm going to go over to map. And I'm going to scroll down until I hit RREF. And it is towards the bottom. So there's REF, I want RREF. Here it is, option B for this calculator. And then I'm going to go back to matrix. Oh, hit the wrong one. There we go. And choose my matrix and hit enter. And so here's what it gave me. Let me go back to my other screen so I can show you guys how to interpret this. Okay, so when I did RREF, I got 1, 0, 0, 0, 1, 0, 0, 0, 1, -2, 0, 3. Okay, so this is the result of RREF. Okay, now the first thing I want to talk to you guys about is how to know if it worked or not. The one downside about RREF is it doesn't tell you if something doesn't work. So here's how you can tell. If you have a diagonal row of ones and everything else is zeros, you're good. So must have a diagonal row of ones and everything else is 0. If you've got other numbers in here, let's say this was a 7, then that would indicate that it did not work correctly and there was no solution. Okay, so you want that. Now, if that's the case, remember this first row was X, second one was Y, and this was Z. So this says that X is equal to 2, Y is equal to 0, and Z is equal to 3. So there's your 3 answers. Boom, done. So, and this scales. Let's say that instead of a 3 by 3, let's say that you had 7 of these, or 8 of these, or 9 of these, or 10 of these. It scales. You can type it in your calculator, make that matrix as big as you need, and you're good to go. As long as you end up with a diagonal row of ones and nothing else, you're done. All right, so that finishes up an introduction to matrix. We will go back over this again when we get to partial fractions, and then we'll go back over it again in calculus 3 and 4. All right? So just let me know if you have any questions, and I'll let you guys go get started on the homework.